Today we're going to be doing lesson 3 in the workbook, Integral Exponents, on page 77. So remember, integral is like a fancier word for integer. So we're talking about exponents that are now positives and negatives. So similar to that investigation that we did on the zero exponent, we're going to do this one with integer exponents. So we know 10 to the power 0 is 1. The pattern we discovered last day is as I go down each column, we're dividing by 10. Therefore, if I have an integral exponent, so a negative 1, well, 1 divided by 10 is simply 1 over 10, which I also could express 10 as just 10 to the power of 1. So if we take it a step further, then 10 to the power of negative 2 is going to be 1 over 10 squared, or 1 over 100. And again, continuing that pattern, dividing by 10, it continues with that same process. So I get 1 over 10 cubed. On this side, they did it with 3s, so 3 to the power of 0 is 1. We're dividing by 3 as we go down this column. 1 divided by 3 gives me 1/3. 1/3 divided by 3 gives me 1 over 9, which is the same thing as 3 squared. So this is then 1 over 3 cubed. So to make our general rule, so this would be an investigation if we could, a to the power of 0 is equal to 1. A to the power of negative 1 is then 1 over a to the power of 1. 1 over a squared and 1 over a cubed. Similar to fractions, you always want to have your answers a reduced fraction. Ideally, with integral exponents, you always want to have positive exponents. So quite often questions will say express the following with positive exponents. Then it's just basically writing them as a fraction. So 1 over 10 to the power of 7, 1 over 3 to the power of 5, 1 over a to the power of n. So the next question says 5 to the power 4 divided by 5 to the power 7. If we were to write this one out, because remember, when in doubt, expand it out, I end up with 5 7s on my denominator. I can cancel them out, and I'm left with 3 on the bottom, so I can write it like that. 5 to the power 3 is 1 over 125. This would also be equivalent as to 5 to the power of negative 3. But like I said earlier, this is not proper form. We always want positive exponents. I just wanted you guys to know that it would be equivalent. So in this one, we would do 4 minus 7 gives us 5 to the power of negative 3. So comparing that, I then can say a to the power of p right there. So these next ones, write the following with positive exponents and evaluate. That evaluate term means give us an answer without an exponent. So this is equal to 1 over 2 to the power of 1, which is then 1/2. 1/2 is your answer. This is 1 over 3 squared, which is equivalent to 1/9. 1 over 4 cubed, which is 1 over 64. Okay, turn the page. Show the rule for division of fractions to show that 4 to the power of negative 1/3 is equal to 4/3. You can confirm with the calculator, but what this is getting at is actually going through that process. So right now we have 1 over 4 to the negative 3. So that's in my denominator. So we still have 1 over a fraction now. When we divide fractions, we multiply by the reciprocal. So my numerator, kiss and flip, you've heard it that way too. Reciprocal, so my bottom piece becomes my numerator. My 1's cancel out, so I'm left with 4 over 3 equals 64. Hopefully, you have your calculators with you, and you could actually type that into your calculator. You will also get 64. Make sure you're using a negative and not the subtraction sign. So negative exponents are law. So our base, this doesn't include 0. This is our big piece. You want to highlight this, but this is what we've just written out and discovered. You have to be comfortable and good with your negative multiplication and division. Okay, so let's do this first one. Maybe let's not. So normally I'm multiplying, so that means I add. So we do 5 plus negative 3, which gives us 4 squared for a final answer of 16. That evaluate piece means we're actually answering. So my next step, 3 to the power of 2 plus negative 5, 3 to the power of negative 3, so 1 over 3 cubed, which is 1 over 27. I'm going to skip this next one just so we have a little bit more space. So here I'm going to subtract. They have the same base, so 6. So I get negative 7 minus negative 5. Two negatives together means I'm adding. So I get negative 7 plus 5, which gives me negative 2. So 1 over 6 squared, 1 over 36. E, I'm multiplying. So I get 2 to the power of negative 3. So that's 1 over 2 cubed, which is 8. Identify the following as true or false. I'd like you to go through these. So pause the video, try them on your own, and then you can compare your answers with mine. So take a moment and go through them. The two that are really important that I want to make sure you're reviewing. So on B, 4 to the power of negative 1 gives us a different base than my numerator. If I convert that to be 2 to the power of negative 2, I still get 4 at the end, or a quarter I should say. At the end of the day, I get two different answers from that. So you have to have the same base to be able to do any of these operations. And on D, what's really important to note, only the A has the exponent attached to it, not the 9. So that's a really easy place for mistakes. These next ones, again, I want you to pause the video and then check them after you've tried them all on your own. It's really important that you're trying these and not just following along with me. So press pause, try them all, and then check over your answers with mine. So on this one, look them over and compare our answers. A couple I would like to highlight first. On E, you can do that division, 8 divided by 4. Same thing with B. What's really important with E to know is I have a negative exponent in my denominator and the numerator. So these basically just flip-flop spots. And on F, you're only moving my numerator down because the denominator already had a positive exponent, and then we expanded out just because we gave the full answer here. That's all. So I hope those went okay for you. Again, pause, and you should be able to look at those. This next question, there's lots of steps here. I'll go through it in detail on how I would solve this one, but again, there's a few different ways you could do this one. Remember when you're answering these, do what works for you. So I would think of this one, the division, because there's a lot here, I'm gonna kiss and flip right off the bat. So what I mean by that is my first term stays the same, and then I multiply by my reciprocal. So the denominator moves up, and my numerator moves down. Now I'm going to deal with combining my like terms, and then I'll deal with my negatives. Again, a few ways you can do this. So to start off with, I'm going to deal with my wholes. 5 on my numerator, 15 on the denominator leaves me with a third. Divide each of them by 5. My x's, I have 3 x's here and 5 here, so that means I have 8 x's on my numerator. Z's, I have y's, negative 8 and negative 3, so really I have negative 11 y's. And my z's actually are going to cancel out, negative 2 plus 2. My denominator, I have nothing to combine, so I'm just going to rewrite it at this point. From here, visually, I can see right away my x's are going to cancel. My y's, I have negative 11 of them, but that's in my numerator, so those are going to move down. So I'm left with 1 up top, 3, and then y cubed, y11, z's to the power of negative 1, so that guy gets moved up. So then I get z to the power of 1 over 3, y to the power of 14. You don't have to write this one here. That's optional, right? Because often we would just say 2 versus 2 to the power of 1. Those are the same things. So it's kind of optional at this point. I don't care if you do, don't care if you don't. On this one, can you explain why 2 to the power of 2p to the power of negative 3 is not equal to 1 over 2p cubed? This would be a really good level 5-6 question. So on this one, it's not equal because the exponent only applies to the p. So it should be like saying 2 to the power of 1 times p to the power of negative 3, which is then 2 over p cubed. Okay, our last little chunk of this. So fractional exponents. If I look at this, 2/3 to the power of negative 4, I could write that then as 1 over 2/3 to the power of 4, which is then really 2 to the power of 4 is 16, 3 to the power of 4 is 81. Then I'm multiplying by that reciprocal, which just gives me 81 over 16, or 3 to the power of 4 over 2 to the power of 4. Do you see a pattern? Well, look at this next one. 3 to the power of 4, 2 to the power of 4, 81 over 16. We're just putting that 4 exponent on each piece here. This following statement is totally true, because what would happen is you're just going to flip my inside pieces to make sure that that 4 becomes positive. A quick method for doing this without a calculator. Well, this is going to become 2 over 5 cubed. 2 cubed, we all should know is 8. 5 cubed, we all should know is 125. So this is our general rule. To make it positive, you can just flip-flop those fraction pieces. So now that you've watched the video, these are the practice questions we'd like you to do. Please contact your teacher if you have any questions about this topic or previous topics. It's really important that you're reaching out to make sure that you know the content as we're going before it gets to be more difficult. Have a great day.